Hello, good evening. My name is Peter Abugri, and I'm going to be talking on machine learning. And the data set to be exploiting is DNA microarray gene data set, made up of whether a person is having a prostate cancer or not. And the data set is made up of 500 independent variables or variables and then 79 observations. So clearly we have case of dimensionality here since our number of variables are more than the observations. So first of all, I have to look at the classification or the distribution of my response variable. So I run this plot to know whether the class, which is the response variable, whether 0 a person is not having or a person is having 1, whether it's a balanced or an imbalanced um, response variable. And clearly it was a balanced response variable. So I went further to explore on whether out of the 500 independent variables, which of these variables influences strongly on the prostate cancer, whether a person is having a prostate cancer or not. So I ran the Kruskal-Wallis statistic test, and as it can be shown, so the features can be shown at my left hand side, and then their corresponding statistic is also shown at my right hand side. So this is the top 9 influencers of prostate cancer. So I further went on to run this diagram to clearly show which of these variables influences. So I went further again to now build these variables using decision tree, and I chose a complexity of 0.01, and the root was x201290, and funny enough or likely enough, the decision tree was able to detect this variable, and it was also part of the 9 most strongest correlated variables that was able to determine by Kruskal-Wallis statistics previously, as shown here. So that was my root, the root start of the decision tree. So I went further. The split, my threshold was 1.1, so I started with 1.1, so which shows that if this feature is greater or equal to 1.1, it means that yes to my left and no to my right, depicting that the person does not have. Then here I further splitted the data into 2. So this variable x214, which was also part of the Kruskal-Wallis test statistic, has also been able to influence, which says that if its threshold, which is negative 0.29, if you are less than that, it means you do not have, but if you are greater than that, you have, which you also have. Likewise, my right hand side, a variable x209048 was also an influencer in the Kruskal-Wallis statistics, so no wonder it also appeared in the decision tree model. That one also has a threshold of negative 0.063. So if you have a feature which is greater or equal to negative 0.063, my decision tree classifies you as not having, and if you are less than that, it classifies you as having. So this decision tree has been able to help policymakers in the health sector to physically or visually interpret this model, in a sense that if you have these features, this feature 1, 2, 3, these 3 features will be able to tell you whether if I test and the person is having this kind of signs, then clearly the person is having a prostate cancer, and if the person is not having, based on these criteria, then the person is not having a prostate cancer. And these features, the most important thing or the most happiest thing I've recognized is that these 3 features has appeared in my Kruskal-Wallis test statistic, and even if when I ran the box plot as well, these variables also had an influence in separating the classes. So thank you so much.